Alright, now let's work a problem without having all of the distractions in our way here. Okay, first of all, let's make sure this is a standard maximization. Let's see, we're maximizing, obviously. This constraint is less than or equal to a non-negative number, and this constraint is less than or equal to a non-negative number, and we have our non-negative constraints. Okay, so we have a standard maximization problem, and therefore we can actually solve this with the simplex method. Okay, now remember, the first thing you do is write your initial system of equations by adding slack variables to your less than constraints. So take this constraint and add a slack variable to it and convert it to an equation, and I get x1 plus x2 plus s1 equals 24. Then take this constraint and add another slack variable to it and convert it to an equation, and I get 3x1 plus 2x2 plus s2 equals 60. Then take my objective function and move all the terms from the right over to the left, and that'll of course change their sign. So 40x1, when you move it across, becomes minus 40x1. 35x2 moved to the left become minus 35x2, and the p stays over there, and then you have 0 on the right. Okay, then we're going to write this in an initial simplex tableau. So usually it's best to identify your columns first. That way you make sure you have plenty of room for everything. So I'm going to have a column for x1, a column for x2, a column for s1, a column for s2, and a column for p. And then if I write the coefficients of the first equation here, I've got 1s1 plus 1s2, x2, 1x2, and then 1s1, and then there's no s2, p, or p, and then you have 24 for your constant. The second equation over here, the 3x1 plus 2x2 plus 1s2, and then 60 for the constant. And then the third equation, the coefficient of x1 is negative 40, the coefficient of x2 is negative 35, and then there's no s's, but there is a p, so 1 for 1p, and then 0. Okay, now notice, like I told you before, it usually starts out where your objective variable p and your slack variables are your basic variables. So it kind of starts out as like a worst case scenario, because if it starts out like this, you know, s1 is basic, s2 is basic, and p is basic, then that means that x1 and x2 would be 0. And that to me would be the worst case scenario, would be if x1 and x2 were 0, then of course p would be 0. Okay, now the reason I know that S1, I'll say this again, I said it earlier, the reason I know S1 is associated with row 1 is because the 1 in the 1, 0, 0 column is found in row 1. And then I know S2 is associated with row 2 because the 1 is found in the second row. And I know P is associated with row 3 because the 1 is found in the third row. Okay, now on this one we're not going to talk about what might have been if we found the solution right here. Let's just go ahead and solve this. Now notice, as long as I have negatives on the bottom row, I know I don't have the optimal solution, so I'm going to have to do the pivot operation. Now, but the problem that I'm going to run into here is I've got to determine the pivot element. Well, it's not really a problem, but it's a step that I have to do. So I know that negative 40 is the most negative indicator, so negative 40 is in the first column, so that's going to be my pivot column. Okay, and that tells me that x1 is about to enter. And then to determine the pivot row, I need to divide these two numbers that are above the negative indicator into their corresponding constants. So if you divide 1 into 24, you get 24. And if you divide 3 into 60, you get 20. So I picked the smaller of those two quotients, which is 20. So that means I'm going to pivot on the second row. So that means that my pivot element must be where the pivot column and pivot row intersect, which is this 3 right here. And so again, let me repeat, x1 is going to enter, and since we're pivoting on the row that S2 was identified with, S2 is going to exit. So we're going to pivot on this 3. So let's go ahead and go through the pivot operation. So to do the pivot operation on this 3, I have to multiply this row by 1/3 to make it a 1. So multiply everything in this row by 1/3, and everybody knows how to do that. So that'll make this a 1. And then I want to use the 1 to eliminate this 1. So I'll do minus row 2 plus row 1. And you guys know how to do that. Minus 1 plus 1 is 0. Minus 2/3 plus 1 is 1/3. Minus 0 plus 1 is 1. Minus 1/3 plus 0 is minus 1/3. Minus 0 plus 0 is 0. And minus 20 plus 24 is 4. Then I want to get rid of the negative 40, so I have to multiply this row by 40 and add it to this row to cancel the negative 40. So 40 row 2 plus row 3. Well, 40 times 1 plus negative 40 is going to be 0. Now here you're going to have to get some common denominators. 40 times 2/3 is 80/3. Add it to negative 35. That's a negative 105 over 3. So 80/3 minus 105/3 gives me minus 25/3. 40 times 0 plus 0 gives me 0. 40 times 1/3 is 40/3 plus 0 gives me 40/3. 40 times 0 plus 1 is 1. And 40 times 20 is 800 plus 0 is 800. So I've completed my first pivot here, but notice I still have a negative on the bottom row. And since that's the only negative on the bottom row, that must be my pivot column. So now my pivot column has to be the second column. And then to determine the pivot row, I have to divide these numbers into their constants. And these numbers have to be positive numbers, by the way. So, and they are. So divide 1/3 into 4. 4 divided by 1/3 is 4 times 3, which is 12. And then divide 2/3 into 20. 20 divided by 2/3 is 20 times 3/2, which turns out to be 30. So 12 is obviously smaller than 30. So this would be my pivot row. Now I don't have the columns labeled here, but this is the X2 column. So I know X2 is going to enter when I do this pivot, and this row is associated with S1, so S1 is going to exit. Alright, now I know where the column and the row intersect is right here at the 1/3. So I'm going to pivot on that 1/3. So what I'm going to do next is I need to multiply this row by 3. So multiply that row by 3. 3 times row 1. And you know how to do that. So just multiply everybody by 3, and that'll give you this row. Okay, and remember I'm pivoting on this 1. So I need to eliminate the 2/3 that's below it. So multiply this row by negative 2/3 and add it to row 2. And let's see if we can do that. Negative 2/3 times 0 plus 1 gives me 1. Negative 2/3 times 1 is negative 2/3 plus 2/3 gives me 0. Negative 2/3 times 3 is going to be negative 2 plus 0 gives me negative 2. Negative 2/3 times negative 1 is 2/3, and 2/3 plus 1/3 is 1. Negative 2/3 times 0 plus 0 is 0. Negative 2/3 times 12 would be negative 8, and negative 8 plus 20 is 12. And that takes care of that. And then I have to get rid of the negative 25/3, so I have to multiply row 1 by positive 25/3 and add to row 3. So let's do that. 25 times 0 plus 0 is 0. 25 times, I'm sorry, did I say 25? 25/3 times 0. 25/3 times 1 plus negative 25/3 is 0. 25/3 times 3 is 25 plus 0 is 25. 25/3, let's see, times negative 1 would be negative 25/3. If you take negative 25/3 and add it to 40/3, you get 15/3, which is 5. And then 25/3 times 0 plus 1 would just be 1. And then 25/3 times 12, that would be 100. And then 100 plus 800 would give me 900. Now you can see that, see the 1, 0, 0, so X2 entered, and the 0, 1, 0, X1 entered on the first pivot, and then X2 entered on this pivot, and the P will never exit. It'll always be a basic variable. So if you take a look at your basic variables, this tells me that x1 and x2 are both basic variables, and then the other column with the 0 and 1s in them is the p column. So that means again that s1 and s2 are non-basic, so they're 0, so we can just kind of mark those columns out so we can read the solution. And now if I look at the first row actually identifies x2. So x2 is the basic variable identified with this row, so x2 is 12. The second row identifies x1. I really don't have room to write that, but it's x1, and it identifies as 12. And the third row is for p, and p is identified as 900. So my optimal solution is p would be 900 when x1 is 12 and x2 is 12, and then s1 and s2 are 0 because they are non-basic. So that's the optimal solution for that problem. And if you want to do a practice problem before you move on, here's a problem here that you can practice on solving using the simplex method, and the answer is given here. So just make sure you can get that answer. And in the next video, I'll go ahead and start with an application problem, and we'll work a word problem in the next video.